Redox. So this is how I will write it. Why do we call them redox? It means reduction. Red is for reduction. Ox is from oxidation. So redox reactions are also called oxidation reduction reactions. Let's now go to our slides and see. So you say reduction and oxidation. One is for reduction, the other one is for oxidation. Oxidation is losing electrons. Reduction is gaining electrons. We know that all the substances consist of atoms, right? So atoms have nuclei, which consist of protons and neutrons, and electrons around the atom. Atoms can take electrons or they can lose electrons. You see this X and Y. X gives his electrons to Y. This is X. And this is Y. If you remember, we were talking about electronegativity. So, electronegativity is able to attract electrons of another atom. If he is more electronegative, I will write more electronegative. It means he is stronger. So he will take these electrons. That means that electrons from X will move to Y. Okay, electron, and he will lose his electrons. So if I am an atom, I lose my electron, I become sad, yes, because someone took my electrons. Electrons for them are like money. He lost his money. He's very sad. It's called he's oxidized. Oxidized. While this one is reduced. He's happy. He took electrons, he has much money, a lot of electrons. He is reduced. So he is oxidized himself, but he reduced this one, the other atom. That's why when he is oxidized, he reduces the other one. So he is called the reducing agent. If I get oxidized, it means I reduce the other atom, I will be a reducing agent. Oxidized, but he's a reducing agent. Because he reduces the other one. Okay, this one will be an oxidizing agent because he got reduced, but he made him oxidized, so he is an oxidizing agent. So this is an oxidation reduction reaction that takes place in the nature. If we see here, this is called photosynthesis. Yes, if we have sunlight, carbon dioxide, what happens? Plants have leaves, the green parts of plants, so leaves. They take carbon dioxide from the atmosphere, they take water vapor and sunlight. As a result of the sunlight, photosynthesis process occurs in their leaves. So what happens? These two substances become glucose and oxygen. So as a result of photosynthesis, we get oxygen. Right. Let's go further. So look what happens. Pay attention at this picture. Yes, this scheme. First we have carbon dioxide, right? If you look at the previous reaction. See, carbon dioxide. I write the same reaction that you can see on the slide. Then, we take water, yes, carbon dioxide, water. Then we get photosynthesis. We have light, photosynthesis. I will not try to work with photosynthesis, it's really bad. We get glucose. And we get oxygen. Yes. So this is glucose, and we write this here. Glucose, oxygen, water, and carbon dioxide. Carbon dioxide. And now let's have a look here at this picture. So glucose here. Oh, no, I mean this picture. You will take it later, not now. So what happens here? As we have a pay attention to this one. Look, if glucose, what happens? Glucose loses electrons and hydrogen. These two ones lose their electrons. Oxygen and water, they take electrons. So let's see. Glucose, we say glucose, and what? Oxidation, low electron and hydrogen. And CO2, they lose electrons. Okay? Glucose and CO2. Oxidation is losing electrons, reduction is gaining of electrons. And now let's take such an example. Okay? What happens here? We have lithium and fluorine. On its outer shell, lithium has 1 electron. Fluorine has 7 electrons. Indeed, they always, all the atoms want to have 8 electrons on their outer shell. Now look, for lithium, 7 electrons are missing. For having 8, he needs 7 more. Fluorine has 7, but he needs only 1. Who is stronger now? Fluorine, yes, he has more electrons. He will be more electronegative. He needs only 1. It's easy to take 1 electron only than take 7 electrons. Lithium needs 7 electrons. Fluoride needs only 1. Of course, yes, it will be more electronegative. This fluoride will take this one single electron of lithium, take from him, and we will get lithium fluoride, such a substance, a molecule. So fluoride is oxidizing agent. Because it oxidized lithium, it took his electron and got reduced. While lithium is a reducing agent, it lost its electron, so it's oxidized, and it made fluoride reduce. So it's a reducing agent and oxidized. He loses electron. Fluoride is oxidizing agent. He gained an electron and got reduced. A is reducing agent, loses electrons, gives it to B. We have A and B, the first two ones, yes? He has 2 electrons, B doesn't have electrons. So what happens? A will give his electrons to B. A gets oxidized, yes, and it reduces B. A is reducing agent. He gives his electrons. We have A, yes, with 2 electrons, 1 and 2 electrons. And 2 electrons. And we have B, what's going to be like there, yes, B. So what happens here? This A will give his electrons to B. So these electrons will transfer to B. So as a result, we will get such a thing. A will lose its electrons. A without electrons. Yes. While B will have electrons. This B took these electrons and he has now 2 electrons. He loses electrons, so he is oxidized. Yes, lost electron. Oxidized. Oxidized. So he is a reducing agent, yes. If he got oxidized, it means it was a reducing agent. B took electrons, B reduced. Yes, it takes electrons. is reduced. So he was an oxidizing agent. You see, when we are talking about oxidation reduction, look, the one who gives electrons is less electronegative. The one who is more electronegative, he will take electrons. Okay, he will take electrons, gain electrons, because he is stronger. If I am more electronegative, I have more strength to attract electrons. I will take them. The one who is less electronegative, he is weak, he cannot take electrons, he gives his electrons. It's like here, look at these pictures. We have two humans here. This one, I colored the pink and green. The pink human has 2 electrons. You see in his hands, he has 2 red. Let's say these are apples. He has 2 apples. Yes, red apples. The green one is angry. He doesn't have apples. He doesn't have electrons. See, he's angry. And he wants to take electrons. But he is stronger. So he comes, this one comes and fights with the one, this one, and takes his electrons. He took his electrons, what happened? He is now sad. He lost electrons, he's oxidized, and he's reduced. That's why he's sad. So this one is a reducing agent, oxidized. This is an oxidizing agent, he is reduced. So electronegativity is the ability of an atom to attract electrons of another atom. So electronegativity is such an ability that allows to a nucleus of an atom to attract electrons of another atom. You see, these are 2 electrons that are getting attracted by this atom because he's more electronegative and he attracts them. Look here. This is oxygen, the red one. And the blue one is nitrogen. So oxygen is more electronegative. So we have oxygen and nitrogen. Yes, oxygen and nitrogen. Oxygen is more electronegative. That's why he will take the electrons of nitrogen. So atoms of electrons of nitrogen atom went to the oxygen atom because oxygen is more electronegative. So if we are talking about the opposite of electronegativity, that will be electropositivity. So electropositivity is the ability to give electrons. If oxygen is more electronegative, nitrogen will be more electropositive. This is the table of electronegativity. Let's say they took lithium and said, okay, lithium will have electronegativity 1. And they considered it as 1. See? And after that, they found that fluorine is 4 times more electronegative. It's 4 times stronger. So if they consider it was just a that lithium will be 1, and all the others were just made in comparison. So beryllium was 1.5 times stronger, so they made it 1.5. Hydrogen 2.1 times, etc. Like that. Fluorine is 4. It was 4 times more electronegative than lithium. So its electronegativity was considered as 4. The least electronegative or the most electropositive one was francium. Also cesium. Cesium and francium. These 2 ones have electronegativity 0.7. So lithium is 1, fluorine is the strongest, for francium the weakest is 0.7. So in this direction, from down to upside, and from left to right, in this direction, electronegativity increases.